This is question 12 on the worksheet on forces on inclined plane. A small box of mass 5 kg is pulled at a constant speed of 2.5 meters per second. Okay, constant speed means acceleration is 0. Down a line of greatest slope of a rough inclined plane. Rough inclined plane means there's definitely friction, which is equals to mu r. Okay, let's draw an inclined plane. 10 degree, and there's a particle, small box of mass 5 kg. Okay, and this is 5 kg, so that would make this 10 m cos theta. So 10 m would be 50, 10 times 5, and cos 10, this is one component of weight, and down the slope is the sine component of weight, 50 sine 10. Okay. Upwards is always the normal contact force, and since it's going down the plane, there's going to be friction in the backward direction, and friction's unit is, or friction's formula is mu r. And the pulling force has a magnitude of 20 Newton. There's also another pulling force. Maybe there's a string pulling this downward or whatever. So there are actually two forces in this direction, 20 Newton force and 50 sine 10, which is the component of weight in the downward direction. Find the coefficient of friction between the box and the plane. So we're going to use forward force minus backward force is equals to ma, which is Newton's second law. Forward force minus backward force is equals to ma. So 20 plus 50 sine 10, both of these are the forward forces, minus there's one backward force, mu r, is equals to mass times acceleration. Mass is 5. Acceleration is going to be 0 since it's constant speed. Okay, now we have to find the value of mu, and r in this direction is equals to 50 cos 10, since these two forces cancel each other out. So r is going to be 50 cos 10. Now I'm going to move the mu value to the other side so that it becomes positive. And here we have 20 plus 50 sine 10. Then we're going to divide this on both sides. This should give us the value of mu, which would come out to be 0.58. 5824, rounded off to 0.582. Let me quickly check. This answer is correct. Next, it says the pulling force is removed while the box is moving at 2.5 meters per second. Okay, let's say somewhere over here, well, when the box reaches here, the pulling force is removed. So now it becomes 0 instead of 20 newtons. And find the distance moved by the box after the instant at which the pulling force is removed. So when the pulling force is removed, the speed was 2.5, so u is still 2.5. Let me write that down. And we have to find the distance that this particle moves, and then the final speed would be 0, because that would be when the particle stops moving. And we need the value of acceleration for this setup. We cannot use the same acceleration as before, which was 0, because now the system has changed. And now there's 0 instead of 20. We had 20 earlier. Now we're going to write 0. Forward force is 0. But this component 5 sine 10 is still there because that is because of the weight. 50 sine 10, I'm sorry. So 0 plus 50 sine 10 minus backward force is the same thing, the friction that we got earlier. So we'll have to use mu r again. So mu was 0.5824 and r is 50 sine 10, 50 cos 10, I'm sorry. So we're doing forward force minus backward force is equals to mass times acceleration. Mass is 5, and we're going to find the new acceleration. So we divide all of this with 5. And that should get us minus 3.999. So minus 4. Most probably because of a little rounding here, we're getting minus 0.399. Had we used the exact value of mu that we got in the calculator earlier, we would directly get minus 4. Okay, so now we're going to use this acceleration here. It's minus 4. Okay, so this is going to be, how do we find S? We can use V squared equals U squared plus 2AS. So 0 square is equals to 2.5 square plus 2 times minus 4 times S. Solve this and get the value of S, which comes out to be 0.781, rounded to 3 significant figures.